This paddleboard project is to demonstrate the Jumbo 3 boards. This 14-foot paddleboard diagram fits the Jumbo 3 perfect. I was able to digitize his full-size plan, including the profile frames. I did use Logitrace 2018 to draw the frames. And my favorite, I'm using tracing polylines. You can see here I put a red mark where I start, and the reason I do that, I don't want to have a cross vector by coming around and redrawing a spot that I've already drawn. I always leave about an 1/8 inch from my starting point, and I let the computer fill in that last bit. Those little keyhole looking things, those are fillets, and that's to give the stringers a bit of relief when you glue them, a place for the glue to kind of sneak out. So when you draw a fillet, you don't have to be exact because it's just a place for the glue to sneak out. It can be perfectly round, it can be jagged, it doesn't matter. It's just a relief. All the frames that I drew out, they were all full size. After I completed each frame, I created a file, saved my work. These frames are going to be 1/2 inch birch plywood, and the rest of the paddleboard is all 1/4 inch mahogany plywood. It was easy to draw out the frames because the frames are all pretty well straight. It's just to go into those little fillets. That took a few minutes, but like I said, it doesn't have to be accurate. I also used the text label. That's kind of neat. You're able to put the frame number right into the file. Once these frames are all drawn out and digitized, then I'll put them into Vectric Aspire and do my toolpath and also do the nesting so I can get the best cut out of a 4x8 sheet to take all these frames out. I also labeled the paddleboard large diagram showing all the frame locations because I'm going to take that paper plan and that's how I'm going to set up the frames and the stringers. I'm going to go right on top of the paper plan. So that's going to be a really good accuracy check, and I'll show that. You can see here the text label that I'm adding. I like that. Again, I saved and created a file for each frame. I've used these fillets before. I found that sometimes when you tap in a stringer in a tight slot, it will actually break up the plywood. So the fillets are not only a glue relief, but it gives the wood a bit of a relief too. Now I'm going to load those frames into Vectric Aspire 9.5. I'm going to check the vector quality and make sure there's no open vectors. I had placed all the frame files into two groups, two large files. Once I was happy with all the vectors, then I nested it, as you can see here, all on the left-hand side of a 4x8 sheet of plywood. I'm getting ready here to draw out the full-size diagram of the paddleboard. I just wanted to mention the two reference points that the Jumbo software asks for in case you have to move your diagram to the left or right. Here I use the Jumbo configuration test just to check out the COM ports of the three boards. This gives you a readout for each board. And then you're good to go for digitizing. Here's where it asks for the two reference points, one on the left-hand side, one on the right-hand side, or one on the bow, one on the stern. So if you have to reload the file, there will be alignment between these two reference points. It will remember where that diagram was on the Jumbo 3s. It doesn't take a long time to draw out such a large plan. It's just a lot of walking to go all the way down to the bow and then come all the way back to the stern. I started at the bow, went all the way down one side around the stern and back up to the bow where I finished it off. You can see here the two null points between the three boards. So if you had to draw something intricate right at that spot, you'd have to move your diagram to the left or right, and that's where the reference points pay off. That's the alignment that you need. I don't save anything here until I do the full diagram, and then I create my file. I'll be coming around the bend here to digitize the bow, the circular part. So we're pretty well halfway done. So again, those cross members you see, like that frame number 1, that's just for my reference to add the frames and add the stringers after I've cut them out. All the frame profiles marked out on the paper plan will enable me to put those frames back on the paper plan and start adding stringers, and I'll get the accuracy that I want between each frame. It also saves doing a lot of measuring between the frames because it's already laid out on the paper plan. So we're coming up to the bow, which is going to be the end of my tracing, and I'll just get within about 1/4 inch of where I started, and I'll let the computer close up that vector. and then I'll create the file. It's finished. Then I'm going to take that saved file, I'm going to put it into Vectric Aspire, check the vector quality, make sure there's no open vectors, and then I'm going to split that top so I can cut that out of a 4x8 sheet, 1/4 inch mahogany plywood. Here I took that frame nested file and I'm cutting out each frame. And I also labeled them on my board just because some of them look so close to each other they're going to get mixed up. It took 50 minutes to cut out the frames. And like I noted, this is a 4x8 sheet of 1/2 inch red oak plywood. By nesting these frames, I was able to only have to use 13 inches by 98 inches, so I had 3/4 of a sheet left over. All the frames are tabbed, of course, because if you didn't tab them, they'd come flying out, especially when I cut that fillet. All my videos are sped up because I don't want you to be watching this on and on and on real time. Here's a neat shot showing all the frames cut out. All I did then was I took a chisel, I cut into the tabs and pulled each one out. I laid out the full-size diagram on my workbench. I was lucky to have the 16-foot bench, and there I placed all my frames and started to do the stringers. The stringers all fit perfectly. Using Vectric Aspire 9.5, I'm going to load the files that we created to cut the top and to cut the sides for the paddleboard. Here I'll create the toolpath for all the parts we need. As you can see, we need 2/4 inch mahogany sheets of plywood, and I nested all the parts to cut down the waste. Shown here, we're running the CNC machine to cut out our parts. I'm using a 1/4 inch carbide end mill, about 19,000 RPM at about 65 inches per minute. All the parts were tabbed because it's 1/4 inch plywood. If you don't tab it, it's going to fly out and damage the plywood. All the parts were cut in 2 passes. Shown here, I'm not using the dust pickup, the normal dust pickup I use in the CNC machine, because I want to be able to show the cut clearly. Took about a ½ hour to cut each sheet. Actually, the second sheet was a little bit quicker because it was just I only used about 13 inches off the sheet. You can see here the paddleboard sides are cut, and in this shot the paddleboard top is cut, 2 pieces. This shows the accuracy of the draw and the cut. Here I fitted the top back onto the diagram and it fits perfect. The plywood lines up with the marks. Shown here, I've glued the top on. You're looking here at the bottom of the paddleboard. It's very strong because of the stringers and frames, and it's not hard to handle, but it's long. It's not heavy. Most commercial paddleboards that I've seen are around 12 feet. This was an interesting project for me.